Okay, guys, so the second part of today's lesson of chain rule is something that we call Leibniz notation. Okay, he was a famous mathematician around the same time as actually Newton. Okay, um, so what this says is that if we're able to split, this is like a composition of functions again, right? If I'm able to split something, a function y written in terms of u, and then we actually have u written in terms of x, we can use this notation to find the derivative dy dx. How does it work? Well, it says that dy dx is dy by du multiplied by du by dx. And if you actually look at the notation there, well, then these two things would essentially cancel out, right? And you'd be left with dy dx. So if I were to find the derivative of each of these individually, okay, then I could multiply the results together and find the derivative. Okay, so let's do that. Let's say dy by dx is equal to dy by du multiplied by du by dx, right? So I'm deriving y with respect to u, and then I'm going to derive u with respect to x. Okay, so I'm going to we'll do those. Dy by du, that's going to equal the derivative of this. So we're just going to apply our power rule, right? So we're going to say 2u plus 6. And then du by dx will equal 6x plus 1. Okay, so then Leibniz notation told us we can multiply these two things together, right? So I'm going to say, okay, well, dy by dx is going to equal 2u plus 6 multiplied by 6x. Okay. Now the problem here, I have x's mixed in with u's, but that's not a huge problem because I know what u is equal to, right? So let's bring it back up here, and we'll just replace the u with what it's supposed to be. Right? So we can say 2 times 3x squared plus x plus 6. That has to get multiplied against 6x plus 1. So we're going to get 6x squared plus 2x plus 6 multiplied against 6x plus 1. Okay, and then we can expand that out, and we're going to see that we get 36x cubed plus 6x squared plus 12x squared plus 2x plus 36x plus 6. And clean it up, we get 36x cubed plus 18x squared plus 38x plus 6. That's our final answer. This is dy by dx. Okay, so we have composite functions. Okay, functions inside of functions. This is chain rule. Right? It's just a different notation. Functions inside of functions and taking their derivative is chain rule. And this is just a different notation. Okay, so that's option one. The second option could be, well, right off the bat, why don't you just replace the u inside the functions and see what happens? Okay, so why don't we just say, okay, well, y equals, we're just going to replace the u's with what it tells us u is equal to. Okay, and then if I were to do some expansion work, so remember I'm just trying to clean up this y expression. I'm going to get, remember it's square the first, first times last times 2, right? So we're going to get 9x to the power 4 plus 6x cubed plus x squared, right? That's this expanded out. And then we're going to add 18x squared plus 6x. And we clean it up. So we get y equals 9x to the 4 plus 6x cubed plus 19x squared plus 6x. I can now, you'll notice here, there are no u's, right? And conceptually that makes sense because we got rid of the u's right from the very beginning. But we are free to find the derivative, dy by dx. If I were to derive this equation y, with respect to x, there's no issue because I only have x's in each of the terms. There are no u's anymore. Right? So we've made this direct substitution from the very beginning, function inside of function, right? And now we can just derive this. Well, we're just going to apply our power law to each one of these terms, 4 terms individually. So we're going to get 36x cubed plus 18x squared plus 38x plus 6. And there you go. That's Leibniz notation, right? Dealing with the derivative written in a different form. Okay, so you'll have some homework questions around this. And as usual, if you have any questions, just let me know.